Alright, a projectile is launched straight up from the ground with an initial velocity of 272 feet per second. When will the projectile's height above ground be? 960 feet. So you have a word problem here. First thing I recommend is a picture. Everyone say a picture? So I think of my son. Sometimes he gets upset. He gets upset at his sisters. So what does he do? Sometimes he'll actually take their toys, like a purse, and he'll throw it down. And he's not just that upset, he actually will kick it. So the x-axis is going to be our independent, that's time, measured in seconds. So t measured in seconds. And remember I told you guys it's like writing a function with y's and x's. So your y, your vertical axis, is going to be s, above ground in feet. So we're going to do some highlighting here. A projectile is launched straight up from the ground with an initial velocity of 272 feet per second. Class, which variable is initial velocity? That'll be our v. When the projectile's height above the ground be 960 feet. So my son might kick that purse or that toy actually from the ground. So that is actually your starting point here, right? And then it tells us when will the projectile's height above ground be 960 feet. So mark right here 960, not at the vertex, but a little bit lower. And you kind of want to know this, right? When is a time question. They want to know when, in time, here on the x-axis, does the x values reach here and here. So above ground of 960 feet will be this. So all we have to do is our substitutions. Class, our above ground would be how much? 960. That's what we're looking for. Negative 16t squared plus, what's our initial velocity? And then where is it starting?
0.
It's starting at ground level, so it's actually 0. Think to yourself all the ways you could solve quadratics. Show me that very special number when you're solving quadratics. Show me. When you're solving quadratics, it should be equal to 0. Class, how do I set that equal to 0? So I'm going to have 0 equals negative 16t squared plus 272t minus 960. Now, there's a bunch of ways of solving quadratics, right? My students from the last class tried to use quadratic formula, and it took them like 10 minutes. Because they're saying your a value is negative 16, b value is 272, and your c value is negative 960, and you get very large numbers. But class, what's the fastest way of solving quadratics? It's factoring. So let's take a shot at factoring. 0 equals, and I'm going to take out a, let's see if negative 16 is the greatest common factor. So 272 divided by negative 16 gives me 17. No, sorry. That would be t squared. So I'm factoring out negative 16. 272 divided by negative 16 gives me negative 17. And negative 16 goes into 960 60 times. So that'll become a positive 60. And did you notice that it was a negative? Did you guys see that? If it's a negative, what happened to the math operations? All the math operations actually changed. So now I have a quadratic function there that hopefully will be easier to factor, negative 16. Two numbers, when I multiply them together, equal a positive 60, but when I add them together, equal negative 17. What are those two numbers? Negative 5 and negative 12. Well, to solve any quadratics, it's set equal to 0. When you're factoring, I use the zero product rule. So I set each of these equal to 0. Therefore, t is equal to 5. T is equal to 12. Class, can negative 16 equal 0?
No.
No, never. No solution right there. Not the whole thing is no solution, but you only have your solutions to be t equals 5 and 12. What does that mean? That means when you put in 5 seconds, or time equals 5, t equals 5 into your original problem, mark it right there, 5, it's saying that the height of the purse being kicked up in the air will be 960 feet. And then when you watch something fly, it starts at that point, right? But it also will come down to that same point again, right? So that'll happen at 12. So when will the projectile's height above ground be 960 feet? The answer is at t equals 5 and t equals 12. Question B. When will the projectile's height above ground be more than 960 feet? So I want to highlight this word, more than 960 feet. Think about that. That's an inequality that says S is what? What inequality? Greater than or equal to 960. So if you think about it, if I put this back into the problem, right? You're looking for something where it's above 960. When will, that's still a time question. When will this projectile be in this blue path here?
From 5 to 12.
Between where?
5 and 12.
So let's write that. In inverse notation, that'll be what? Parentheses or bracket? Bracket.
Wait, what?
5. To where? To 12. When will the projectile's height be above ground more than 960 feet? That'll be, in words, that just means between 5 and 12 seconds.
Wait, shouldn't it be parentheses?
Yeah, because if it's 5 seconds, it's 960 and it just says more than.
Yeah, it didn't say equal to.
Oh, thank you. So it just says more than. So this one should be a parentheses. Make it really thick. And then have no inequality sign. So just S is greater than 960. C. When will the projectile's height above ground be less than or equal to, I see equals to now, well, if I do that in, what color have I not used yet? Let's do orange. Less than would be here in orange, right? So all of this and all of this. Class, how can you write that in inverse notation? That spot right there? How would you write that? Good. You can go towards negative infinity, because can you have negative time? No, so it's starting at 0. Can you include 0? Yes. Actually, these are both. Sorry. Both parentheses. 0 to where? Can I include 5?
Yeah.
Because it says equals 2. Class, U or an N? We're going to have a U, because we're looking for less than. To where? 12 to. Actually, we didn't calculate it. You can figure out the X-intercepts to be the origin, x equals 0 and x equals 17, right? You could use quadratic formula and you'll get 17. So between the times of 0 and 5, it's less than 960 feet, and then between the times of 12 and 17.